If I give you a function that can generate random numbers every single time you call it, and those random numbers are uniformly distributed, can you use that function to estimate the value of pi? It might seem impossible at first glance, but trust me, this interview question is way easier than it looks. Before we start writing code, let's deeply analyze the problem and see what kind of algorithm we're going to use. Imagine we have a grid of x and y plane. And now let's draw a square with center 0, 0 and length 2. Now let's call our random function twice, and let's assign the first one to give the x coordinate and the second one to give the y coordinate. Let's say the first one gives 0.3 and the second one gives 0.7. And now we have a completely random coordinate, in this case 0.3, 0.7. Now we will place a dot at this very coordinate. Let us repeat these steps a lot of times, but we will make our function to give us random values from only 0 to 1, so that we will only have to work with first coordinate. And we are done. Now we have enough dots to analyze the problem. Now let's draw a circle in the grid, and the center of the circle is 0, 0 and the radius is 1. And let me just pause here for a second to give you some time to think about it. Can you figure out the problem now? Okay, so the main idea here is if we divide the area of a circle with the area of the square, we'll get a value which is equal to the number of dots in the region of the circle divided by the number of dots in the region of the square. And just to be clear, you can take random coordinates in the entire region rather than just the first quadrant, but that won't make any noticeable difference as we are only considering the ratio. So you know, why waste processing power? So we'll just stick with the first quadrant. And now it's math time. Area of circle is pi r squared, and r in this case is just 1, so pi into 1 squared, which is just pi. And area of square is 2 squared or 4. Now we can find the value of pi by setting it equal to the ratio of the points multiplied by 4. For example, let's say we have a total of 38 dots and only 30 of them are inside the circle. We can find that pi equals 3.15. Now this number does not necessarily have to be exactly the value of pi because we're not taking infinite amount of dots here. So then as the number of dots will increase, the precision of our value will also increase, but it will never be exactly pi. Now let's move to the next step. Finding the number of dots in a square is fairly simple. Basically every single dot we get will be inside the square, as we are taking values only from 0 to 1. But we have one problem. How do we know which dot is within the circle? Well, we can use this simple formula we learned in our high school to calculate the distance of a point from origin. And if the distance is greater than 1, it's outside the circle, else it is inside. Take this point for example, which has coordinate 0.5, 0.5. And if we calculate its distance from origin, we'll get 0.353, which is of course less than 1. So we know this point is within the circle, and not to mention it's also within the square. On the other hand, this point here has coordinates 0.9, 0.8. And if we calculate the distance, we will get 1.20, which is of course greater than 1. So we know this dot is outside of the circle but inside the square. And that's all about the theory. Now let's see some code in action. I'll be using Java for this purpose, but trust me, it's not a lot of code, so you'll be fine even if you don't know Java. Alright, so this is our project here, and it's pretty much an empty project, so yeah. Let's go ahead and create a function, so we'll call it static void, and we'll call it estimate pi. Alright, so estimate pi, and it will take an integer parameter, we'll call it dots. So this is basically the number of dots we want to place in our square, because as the number of dots will increase, you will see that the precision of the value we get will also increase. Yeah, we'll see that in action. So yeah, let's open up this bracket here, and I'll create few variables here. First thing, I'll create a random variable because we will need random values. So random equals new random, And by the way, fun fact, computers cannot actually generate random numbers. They generate what you call a pseudo-random, so that kind of behaves like random but not actually random. Yeah. So anyway, so yeah, let's go ahead and create a next variable. We'll call it inCircle. So this variable basically record the number of dots inside the circle. We'll initially set it to 0. We'll create another integer. We'll call it inSquare. Again, equals to 0. So these are basically the variables we discussed, right? So the number of dots inside the circle and number of dots inside the square. So yeah, now what we will do is we'll run a for loop, and we'll start from 0, and we will loop up to dots. And alright, so first things first, we'll get our x coordinate from here. So x equals random dot next double, and just to show you, oh sorry, this will be a double. Yeah, and just to show you this double, it returns a value that is uniformly distributed, and it returns value from 0.0 to 1.0, exactly what we want. So let's go ahead and get our y coordinates. So double y equals random dot next double again. Alright, so we have our coordinates, and now let's calculate the distance of that coordinate from the origin. So we'll use our formula that we looked before. So it will be of type double. We'll call it d, and it's basically math dot square root is u. Alright, and we need to pass in square root of x squared plus y squared. So that would basically be x into x plus y into y. Now this variable gives us the distance of that point from the origin, and now we'll actually check if the distance is less than or equals to 1. So if the distance is less than or equals to 1, we know that that dot is inside the circle, so inCircle will increment by 1. And no matter what happens, no matter if the distance is greater than 1 or less than 1, we don't care. The inSquare will increase anyway, because every single dot we get will be inside that square anyway, right? So we have our requirements ready. Now we have to calculate pi. So now let's go ahead and calculate our value of pi. So pi would be of double, and we set it to equals 4 multiplied by. So now as both inCircle and inSquare variables, both of them are integer, we cannot just divide them because that would result in 0. So pi would be 0 anyway. So we need to cast one of them to double. So I'll just cast inCircle to double, and then I'll divide it by inSquare. And that's pretty much it. We have solved the problem. Now let's go ahead and print it out, right? So we'll say value of pi with number of dots is pi. Alright, so let's call this function and run it. So estimate pi 10. We'll run with 10 dots and then 100. Yeah, and I'm just calling this function multiple times just to show you how the variation of number of dots affect the precision of the value we get. So estimate pi 1000. Actually, let's go with 10,000 here. Estimate pi, we'll go with 1,000,000 this time, right? Alright, there's 1,000,000. No, okay. Alright, there we go. Let's go ahead and run it. There you go. So yeah, as you can see, the pi with 10 dots is not that accurate. 100 kind of close. 1,000 is close, and look at that. With 1,000,000 dots, we get 3.14. That's actually precise to 2 decimal place. So that's awesome. And I don't know if I can get it to like 3 decimal place. I don't even know what the actual value is up to 3 decimal place, but I'll try with a few more zeros there. So just to check what we get. Okay, yeah, it will take some time. Alright, so 3.1313, I guess it was 3.1315, maybe, I don't know. Yeah, so that's 3.14159. So yeah, we got pretty close. We got like, you know, 2 decimal place. So yeah, that's an achievement, right? Anyway, so that's it for today. I'll see you in the next video. And yeah, if you like this video, hit the thumbs up button, subscribe to stay connected, and let me know if how can I make my videos better for future. So see you in the next video.